Hi, uh, this is Sebastian Sarinana with another video, and we are going to talk about what I'm been doing for the past 9 weeks, which is Python and machine learning. Well, I haven't done a lot of machine learning except for the past week, but what we did this 9 weeks, and this is the point of the video, is telling you what I've done for the past 9 weeks. Is the dream was to make a game and make like the Snake game specifically, and have an AI play it. The point was to make a game and make the AI play it, but we went with the Snake game. My Snake game, no obvious bugs detected, but you can look up Google, and then you look up Snake game, and it goes up, and that game's so much better than mine, so there's a little point to do mine, but let's get on back on track, and we're going to explain how my Snake game works. Now, what happens with my Snake game is it uses Python, which is a programming language, which is what I write my code with. Now, there are many types of programming languages, but that's not what we're going to talk about today. The reality is, well, I made the Snake game, and how I did so is, well, that's not what I'm talking about. I'm talking about the reality. Well, the reality is, it worked. There was a couple bugs, but I fixed them. There was a lot of problem with trying to make the snake body grow longer, but yeah, I found my way around that by learning another function that I previously did not know about. Well, a function is basically what I call, and it makes like a this other type of code. It makes and does like I say print hello world. What the print is a function, and what I do is I say the print, and then I put parentheses, and I say hello world. What happens is that takes that code, and it says, oh, the print function is supposed to print this in the below, and it says hello world, and that's what it returns. Now, what I did is what I did with the Snake game is make a Snake game. I have some experience with machine learning, and I've done a couple tutorials with that. So what I want to do is take the knowledge that I previously learned from machine learning and take that and put that into what I've been doing with the Snake game and play that Snake game. Now, how the Snake game works is by taking a list. Now, a list is what it sounds like. It's a list of things, like a grocery list, where you get your mom to write down a bunch of stuff you want, or that new energy drink you must have from Walmart or something, or that Prime from Logan Paul, I think. Well, we have a list, and what the list does is, for me, it lists all the coordinates I need. Now, I need coordinates because it makes it easier for me. You can do it a bunch of different ways. There's an infinite amount of possibilities you can make one thing. And now I did it this way because I just wanted to. So my game is pretty arcadey. It's like a 10 by 10 grid. And what I want those X coordinates to do is when I'm in this little square right here, and I'm at X5, Y5, so I'm in the middle, I want it to know that I'm there. So it keeps track of all the XY coordinates, and that's what the snake is for. I use it to keep track of the XY coordinates of the whole body, the whole snake. And I'd use that to print out, like I draw, like it says, draw this, draw a little green square at this location, and yeah, basically it makes any little square green where it has the XY coordinate to do so. Now, the movement is actually pretty simple. When a snake eats an apple, it grows, right? So when my snake eats an apple, when my snake goes at the apple, it waits until after it's moved, and then the snake body, the rest of the snake body where it's grown, it goes there. Now, when it grows for more than 2, it basically just has it previously, like when the tail moves, that new body appears. So the snake game is pretty simple. It's a snake game. You move left, you go left. For mine, when you go left, you don't move left by 1. Like you say you want to move left, but you don't get the X coordinate to move just by 1. No, you change the direction to left, and it constantly moves at a rate of 1 to the left. Now, how it keeps track of the speed of that is by having a frames per second. Now, at the end, it waits like a specific amount of time before it keeps doing that, before it keeps doing that, before it keeps moving. Now I could put that up to a ridiculously high number, and you wouldn't even be able to react because of how high the snake is going, like the flash. You wouldn't be able to see the flash. All you see is a blur, and that's all you would see, I guess. Um, Now, the snake has the same rules as the other snake game. If the snake touches the snake body, it dies. If it touches the boundary, you die. The same applies here. If you touch the boundary, the snake dies. If it touches itself, if the snake head touches any other XY coordinates, which is part of the list, it dies. So you don't want the snake to eat itself because it would die of bleeding out or internal failures or eat its heart out or something. There was a couple hurdles. Like I said, I had a lot of trouble with making the snake body make itself better, but as I said, I found a function that helped me take out the data from this list and helped me check that and compare and comparison. All right, now that I've finished this snake game, I'm gonna tell you about what I'm gonna do after this. Well, what I'm gonna do is machine learning. Now this sounds pretty cool. Has machine learning's pretty with AI and stuff. Wow, AI. Well, I have some, like I said, some experience with AI. And what I'm going to try to do is take that experience and I'm going to try to put it in the game. Now I have a bunch of modules that I have, and there's one that I want, but it's not there. So what I'm gonna try to do is I'm gonna go find one from someone else, and I'm gonna use my experience with the other ones to learn this one, and then apply it over here. But I'm also gonna try to take all the knowledge that I have, and I'm trying to see, can I achieve this goal by getting the regression, clustering, classification of this thing. Of course, it sounds like this regression is basically just finding the line of best fit, which is pretty easy mathematically. And classification is classifying things like that's an apple, that's an orange, stuff like that with other data. And clustering is just finding like whether or not this is a cluster or not, which is kind of confusing, but basically that's it. Another stuff that I'm worried about is the data. Where am I going to get the data? Like machine learning, AI, data. Data is extremely important in this process. Now, what I could have is the XY coordinates and then have, oh, is there someone around me? Yes. Then that's a yes. Is there someone to the right of me? Yes. Someone in, different directions. And I could do that. But what I'm worried about is how it counters other scenarios. Like it can only think of like its immediate situation, and it can't think of ahead of itself. Like in 20 moves later, like in chess. Like in chess, it's very important to be strategic and have one chess piece over here, and then later on, that chess piece is extremely important to the other part of chess where you go checkmate, stuff like that. So that's what I'm worried about. And well, this is going to be it for this video. And well, goodbye.